Hello, everyone, and welcome to the next presentation in the Elements of Smart Manufacturing webinar series. My name is Cameron Thurner, and I'll be your host again today. First off, I'd like to mention that the Industry 4.0 program here at GIS and this presentation are sponsored by the Economic Development Administration in New York State. Today is the fourth of 6 webinars, each starting at 11 a.m. on Thursday for the next few weeks, so be sure to tune in to the rest of the presentations. I'd like to remind you that there will be a number of polls throughout the presentation. So when prompted by our speaker, you can go ahead and answer those by clicking the polls tab at the bottom right of your screen and then selecting your answer and hitting submit. Also, if you have any questions throughout the webinar, please feel free to submit those at any point in the questions tab right next to the polls tab on the bottom right of your screen. And we will be saving about 15 minutes or so after the presentation to answer any questions. The topic of today's presentation will be harnessing analytics to drive digital transformation, and our presenter today will be Mike Thurston. Mike is a technical director here at the Golisano Institute for Sustainability and the director of the Center of Excellence in Advanced and Sustainable Manufacturing. So without any further ado, I will pass the stage over to Mike.
Good morning, everybody, and thanks for joining the presentation. As Cameron said, I'm the director of the Center of Excellence in Advanced and Sustainable Manufacturing here at RIT. The center is partly supported by New York State to work with companies in manufacturing and product development challenges they have. My background is in automotive product development and product design, and I've been at RIT working in applied manufacturing research for the last 20 years. That's quick introduction. As Cameron said, this is one in a series on Industry 4.0 technologies. The next two are on, and final two are on the Industrial Internet of Things, August 11th, and then Leveraging Automation, August 18th. If you happen to miss the first three, you can contact us and we'll send you information so you can access replays of those online at your convenience. So today's topic, as Cameron said, is data analytics. So on the agenda, we're going to talk about what it is, why you may want to use it, and then also how to get started. So what is data analytics? Kind of by way of definition, data analytics is the process of examining data sets in order to find trends and draw conclusions about the information they contain. We often find today that we're buried in data, but sometimes it's difficult to extract information. So these tools are part of the answer to solving that problem. So as we said, this webinar is part of our broader series on Industry 4.0. And data analysis is a very important part of the broader Industry 4.0 technology area. Many of the technologies that you see highlighted in the red box, which are Industry 4.0 technologies, deal directly with better and lower cost ways to generate data, move data around, and utilize that data. Data analytics also directly drive the Industry 4.0 benefits that you see, improving the performance of your manufacturing operation through improved decision-making, resource efficiency, flexibility and customer responsiveness, and ultimately speed to market, and also new service offerings for your products. So our first poll today is we want to see what types of data analysis tools you use today in your business. So again, if you go to the poll box and submit your input. So Cameron, I can see the questions, but I can't see the responses. So you're going to have to kind of fill in.
Sure thing, Mike. Yeah, we'll give a moment here to let those votes come in. Again, the polls are on the bottom right. If you want to see the results, just make sure you hit submit after you select your answer. So Mike, if you wanted to see the answers, I think you'd have to submit.
Okay, yeah, I submitted my own vote there. So not surprisingly, spreadsheets is towards the top. We use those heavily, and those are good tools. It's good to see that some people are using, shared dashboards and built-in ERP tools. We do have a couple of votes for we don't do data analytics. And data analytics can be done at many different levels. So I'm sure there's some business analytics that you're doing today, but maybe at the level we're going to talk about here. So thanks for answering that poll. I do notice that really nobody answered that you're using business intelligence tools or machine learning software. These are very powerful tools, and hopefully by the end of the presentation, you'll learn some more about what the benefits are and how to get started with those. So we'll start with the levels of analytics, and this is a diagram that comes from the Gartner Group, one of the large consulting companies that does consulting and research in the Industry 4.0 areas. Analytics can be implemented at many different levels, and you see those here: descriptive, diagnostic, predictive, and prescriptive, and we'll talk a little bit about what those mean. Starting at the bottom left of the diagram, descriptive analytics helps you understand what is happening in the current situation. So kind of track through an example here that maybe helps to illustrate these different levels. So at the descriptive level, you may find out through end-of-line inspection of a machine part that there's an increase in surface finish defects in your quality checks. So you're understanding that there's an issue that's resolved. Diagnostic analytics help you understand the cause of the problem. So as we dig into that problem, analysis of good and bad parts indicates a variation in incoming material properties is likely the root cause of the quality issue that you've identified. Predictive analytics allows you to understand what will happen next. So if I look at a warehouse full of raw material, which may be different than the material I've been running in the past and is generating different results, I can look at the impact of that and estimate that the variation that causes in my process will increase process variability by about 2 times, and that will result in significant increase in end-of-line defects. So now we're kind of looking at the situation and projecting what will happen if I continue to run that material. Prescriptive analytics allow you to determine the best course of action. So given I have this problem, what should I do to offset its impact on my operation? So one solution might be to change the process conditions and bring the process variation back under control with the current material, and thereby prevent the increase in defects. So kind of a simple example, but to try to illustrate as you go along from descriptive towards prescriptive, you get more actionable information. It has more value to the business, but the ability to do these higher levels of analysis requires more information and more knowledge and more effort. So the difficulty and the cost go up. So we're going to talk through the presentation about kind of shop floor or process level analytics and also business level analytics. So kind of, again, just to start out and understand a little bit more what kind of questions we're trying to answer at the process level, we have a couple of examples here. So when should I service this machine to prevent production defects or scheduled downtime? What process variation is causing a particular quality defect? What is causing lack of productivity or low production output in the plant or on a particular line? Do I have the right inventory levels? What operational factors have the greatest impact on on-time delivery? And you can come up with a whole variety of different questions that likely could be answered through greater interrogation of data if you happen to have the right data to support that analysis. And we'll talk about data availability and data needs later in the presentation. So at the business level, some questions we may be interested in are: what factors are most critical to customer retention? What are the characteristics of my best customers so I can maybe handle them in different groups or prioritize their business? What types of marketing and sales initiatives have the greatest impact on orders and profits? What is my forecast for orders? What investments will have the greatest impact on business KPI? So hopefully these questions kind of ring a bell with you, and by the end of the presentation, you'll have a better idea of how the tools can help you answer these types of questions. So data analysis has been done in manufacturing for a long time, but technology convergence in internet data access, data communications, and data processing capabilities, and also data analysis methods have really changed the way that data analysis can be done today. It's easier to integrate data from across different business systems, allowing for quicker turnaround on factors affecting important KPI in a business. Unstructured data such as free-form text can be collected and processed automatically from things like social media, economic data from websites, for example, or from your document repositories. Advanced visualization methods can help people in your organization to more easily interpret complex data sets. And machine learning methods, which we'll talk more about later, are readily available to analyze very complex problems and data sets. In fact, many academic and industry research projects are being converted regularly into capabilities in free software that you have access to. So next we'll talk about what kinds of data are useful for answering the type of questions that we just talked about. At the process level, ERP systems have a wealth of data about the manufacturing operation. Machines are increasingly connected, providing process data. Facility systems such as HVAC can provide data. Maintenance and quality records can be used. HR time tracking and training records. And another software system that's less commonly used today, the manufacturing execution system, which serves as a portal to push information to the shop floor, to your workers, as well as collecting data from operators such as process times, problem reports, quality checks, downtime reasons, and more. So it's a pretty powerful system that not too many small or medium-sized manufacturers use today. At the business level, key systems include, again, ERP, and then, of course, also customer relationship management software, accounting systems, and sometimes these are already integrated together with your ERP system. And really any other data source you can think about, including the process data sources that we just talked about. For most manufacturers today, key business data is more available than key process data for doing this kind of analysis. However, the cost of collecting process data is coming down, while the ease of extracting information from that data is rapidly increasing. So the value proposition is increasing for getting more from your process data and spending the effort to generate more real-time process data. This diagram describes kind of a high-level data analysis process. The process engages different types of resources and stakeholders at different points in the process. Starting at the top, first we identify what types of manufacturing process or business questions you'd like to answer. Then we look at what data we have. So the collection side, what data we have, and close the gaps as needed. This may involve activities to access and integrate data from existing software systems, such as your ERP system. Sometimes you also need to develop processes to filter the data to clean out bad data. And then the next step is developing the analysis methodology and interpreting and using the results. The analysis interpretation phase is often an iterative process involving the data analyst and the stakeholders that have identified the business question. So it may take you a while to get your analysis to the point where it's really providing the value that your business leaders need. It's also helpful earlier in the process when you start defining the initial business questions to think about what analysis methods you may want to use at the same time you're looking at what data is needed. Certain types of analysis methods may need more or less data, and that may affect you downstream. So that's kind of shown as a later step in the process, but you need to have some insight early on to drive your data collection process as well. So you kind of get a little bit of a sense from that what types of resources you may need in the process, but let's dig into that a little deeper. Subject matter experts help to identify and refine the questions as well as interpret the results. Engineers or IT resources figure out how to collect the needed data and may be involved in cleaning or transforming the data. Someone trained in data science technology, such as a data scientist or data analyst, develops the analysis models with the selected tools and reviews the results with other stakeholders. And then we deploy the analysis for decision makers to use. These are different roles in the process. They may not be different resources filling all these roles. In particular, the first three roles could be filled by the same person in the engineering or IT department. Also, as an organization gains competency and data paths and access are set up, good data analytics tools allow decision makers to start doing their own ad hoc analysis. So these tools potentially enable your organization to more broadly become data-driven and increase the value that you're getting from the tools. So that was an overview on kind of an introduction to what is data analytics. Now we'll cover some of the value proposition of why you should consider using data analytics. As we said, it can be applied in different areas within your organization. At the business level, automating reports that you're already doing and providing more rapid updates on business KPI adds value. Data analytics is heavily used by companies to help with customer targeting and market-related issues, as we saw before. And we'll discuss some more applications later in the presentation. At the process level, data analytics can help identify areas to reduce cost, improve quality and yield, improve overall operational effectiveness. As in the case of business intelligence, setting up dynamic reporting on key indicators can make the organization more responsive to issues that may affect customer satisfaction or business performance. I don't focus a lot on product applications in the presentation, but connected products with the ability to collect data from the field allow for data analytics that can improve your customer experience and also often drive new revenue streams. So if you produce a product that can be connected, accessing the data from that and collecting the data and applying data analytics tools can add additional value. And some of the techniques we'll apply would be similar to the process level, but applied on data from your product in the field. The Six Sigma DMAIC process, define, measure, analyze, improve, and control, is the basis of continuous improvement. What you don't measure, you can't manage. Data analytics provides improved capability to manage your KPI and other business drivers. Streamlined data processing with data analytics improves speed of response. Broad cross-system data analysis allows for new types of insights. So as you integrate data across your business systems, and advanced methods allow for us to move towards these predictive and prescriptive type analysis, which can provide optimized direction to control or improve your process or your business KPI. So our second poll question is, where do you think data analytics could provide value to your company? So we'll give you a couple of minutes to provide some answers. So as the answers come in here, they're pretty broadly distributed. And there are a lot of places where, as we've seen, data analytics can have an impact. There's still a couple of people that are not sure. So hopefully you have a better sense of that by the end of the presentation. The general answers are coming in with a little more interest on the process side, helping to identify root cause of quality defects and inventory management, and a little less on the business side. Both aspects are, as we talked about, can add value. And again, hopefully by the end of the presentation, you have a little better sense of how you might go about working on both sides of the data analytics challenge and opportunity. Thanks for your feedback there. So the next section we'll go into is specific data analysis methods. I guess I missed this on my agenda. Starting with machine learning, you may or may not have heard about machine learning. What is it? It's the process of developing a data-driven computational model that aids in interpretation of complex data sets to extract information. So why do we want to do that? When we build the models, what we're looking for is a model that relates a number of input data elements to output data elements or states. And usually we're trying to do one of two things: either classify data, so in the defect detection problem, is this part good or bad, for example, or what kind of defect is it? Or build a more detailed model of the data interrelationships to allow for prediction or forecasting. So in the forecasting problem, you're looking at patterns of data and trying to anticipate what's going to happen next. Is this process, for example, trending towards a failure limit? So it provides better insight into the interrelationships between different data elements. When we do machine learning, a lot of data is generally needed because the models are unstructured and usually don't have built-in expert knowledge. You're basically taking a model structure and learning from the data you provide. Supervised learning requires labeled data sets, and we need that for purposes of classification. So if we're trying to identify what type of defect, for example, I may be generating on a process based on process data, I have to have many examples of that defect to show the machine learning model and to train it with so it can recognize those. You think of facial recognition algorithms, those are trained on millions and millions of images off the internet to learn how to distinguish faces, for example. Now, we do a lot of manufacturing work. Often we don't have millions and millions of images or data elements, but we can make do with on the order of tens to 50 to hundreds of images, although your results usually are better as you get more and more images or data elements. Another aspect of machine learning is that there are many different types of models, and it takes a fair amount of experience to identify what models might work best for a particular problem. But even for an experienced analyst, there's still quite a bit of trial and error involved. Thankfully, with the modern machine learning tools we have today, that trial and error can be done very quickly, and an experienced analyst can go through different model types and determine which one works best for a particular problem fairly quickly. Finally, when we're doing a training, we talked about the need for a lot of data. Part of the reason for that is we need really to break the data into different sets, one for training to tune the model, and then another for testing to make sure that the model works. If we test with the same data that we're training with, it's kind of an unfair test, because the model hasn't learned how to represent data that it hasn't seen before. So very important to separate your training and your test sets to make sure that the model, that an effective model results. So a couple of quick examples from the shop floor. On the left, we're using image data to detect quality defects. This is somewhat similar to traditional computer vision methods, but modern machine learning technologies allow application to much more complicated problems. The picture on the right shows analysis of vibration signatures to assess the condition of a machine. Anomalies can often be detected by training models on normal data, so unsupervised learning. That's useful because if you know your process is out of control and anomalous, you can have someone go in and try to better understand if there's a quality issue or what may be the root cause. If we want to be able to diagnose particular root causes, then we have to, again, have supervised learning, where we have a library of these prior instances that we've done expert classification on to say what the particular problem or the defect is, and then the machine learning method can learn from that classified data how to identify that defect. So hopefully that gives you kind of a quick background on machine learning. These are the other techniques that are often used in data analytics and business analytics, and I'll cover each of these briefly. Machine learning plays into the application of many of these methods, which was one of the reasons I started with that. So statistical analysis, there's kind of two streams here: descriptive analysis or descriptive statistics and inferential statistics. Descriptive statistics describe the data, so that's a pretty obvious definition there. Examples from manufacturing or process control charts, looking at distributions of customer lead times, warranty return rates, etc. And parameters you're likely familiar with, mean, median, mode of a data set. You can look at percentile values. Often in statistical analysis, we use normal distributions, which is kind of the simple bell curve like is shown there. But many times in real processes, we don't have normal distributions, and we need to take into account real distributions that may be uniform or log normal or something else. So that's kind of an important consideration that makes the mathematics associated with working with the data more challenging, but it's sometimes required to make good assessments. So inferential statistics generally are used to support decision making. So they rely on the descriptive statistics, but require some additional analysis. So one thing we talk about there is correlation. Are variables related or independent? So this graphic shows a couple of different types of correlation. The upper left there, a positive, more or less linear correlation, a negative linear correlation. the third graph on the top shows minimal correlation. There's the first two on the second row on the left indicate a level of correlation, where the first one shows less variation and stronger correlation. The second one shows higher correlation. And we can have different types of correlation. So, we talked about linear, but there may be other types of correlation. The other thing to mention is that we often look at data relationships in two variables because it's easier for us visually to process, but these concepts apply to multidimensional relationships as well, many dimensional relationships. So we talked about the shape of the correlation. Regression is a tool that we use to model that relationship mathematically. So linear regression, or we may use polynomial or quadratic type regression, or exponential or logarithmic. But it puts a mathematical formula to the data that can be useful in very useful in modeling. Finally, when we have the data, we want to make sure we're using it effectively and not letting statistics drive us to bad conclusions. So we do testing on the data we have and the sample size to make sure we have enough data to make conclusions with the level of confidence or surety about the outcome that we desire. Other statistical related processes that are very useful in manufacturing: design of experiments, which is basically structured approaches for planning, conducting, and analyzing controlled tests. And ANOVA, analysis of variance, is a method for understanding relationships of many variables and kind of a subset of design of experiments. In the first poll question, Excel came up as a frequently used analysis tool, and Excel can be very useful for statistical analysis. If you have a quality management system, likely some capability is built into that as well. Software like SAS and Minitab facilitate more complex analysis, including the ANOVA that I mentioned. Statistical analysis is the basis of many of the other techniques we discussed, so it's important for data analysts to be well versed in it. When we're looking at, for example, how well does a model fit data that's typically described with statistical parameters, and how well do we think this particular model represents our data distribution. Those kind of questions, once we have the model, are answered with statistics. So a little bit of a drill down on some of the other types of methods that you may find in your business analytics system, your business intelligence system, or that may be useful in the operation. Clustering is a machine learning process that allows the identification of distinct groups in a complex data set. This can be useful for grouping of customers for marketing purposes, by pricing or lead time prioritization, or for detecting production defects, among other applications. Once you have a model built based on, again, kind of training data, you test it to make sure it's valid, and then you can apply it to new data that comes in to determine which group that new data fits into and how you should treat it or how to handle that situation. So clustering can be done with unlabeled data, so unsupervised, and it can also be done with labeled data where you know ahead of time and have decided what group your training data is in. So you've already labeled your data as, if you're looking at a quality issue, for example, as a defect or a non-defect. And that kind of leads to the next one. Classification is kind of similar to clustering, but it's a supervised method, again, where we have to put our data into the classes we define ahead of time, and then we train the model to accurately predict this classification based on other data parameters. So it's kind of, again, you have a set of input data and you're trying to predict some output with the classification model. So applications include product or process defect detection, machine health, customer grouping is mentioned in the clustering example. And also another one, I haven't talked about supply chain, but classifying supply chain risk to production schedules is a good application for classification. Cohort analysis is a specific business intelligence tool that looks at the behavior over time of different groups. It's often applied to understanding customer behaviors. The graphs at the right here were produced with the business intelligence tool Tableau. The upper one shows customer retention trends as a function of time after the first customer order. The lower graph shows declining customer-related revenues as a function of time after the first order. So we look at this group here. This is the September 2016 cohort, the group that first ordered in September 2016. And then you can look at months after the first order, what were their recurring orders and how did that trail off. So this is broken into different cohorts by the month of their first order, and the graphic kind of lays those on top of each other to kind of look at your total order volume and how it's made up of these different cohorts. Factor analysis is a mathematical procedure that extracts patterns from multi-attribute data. In the example, customer survey data has been analyzed to show 3 dominant types of customer behavior: cost-dominated behavior, IT resource-dominated behavior, and organizational dynamics-dominated behavior. And kind of the labels were added after the fact. So somebody did this analysis and got these factor outcomes. This is based on a customer survey. And they decided with cost here, with this group, the cluster of high factors were all cost related. With this group, the high rated factors were IT related. With this group, organizational issue related. So that's kind of the expert overlay on top of the data that came out of it. But it also shows how the cost sensitive group is potentially negatively influenced by other factors, like features, for example. Other applications of factor analysis include using survey data to come up with a means of combining factors into a single customer satisfaction score, or, for example, estimating the strength of different process factors and predicting defects. Many different applications. This particular example comes from Qualtrics, which is a powerful surveying tool and includes a lot of its own statistical data analysis capabilities. There are many types of analysis methods for understanding time series data or relationships between different sets of time series data. Statistical methods are often used. In business analytics, the goal is often to forecast trends. The forecasting example shown in the image here is from Microsoft Power BI. You can see the grayed out range in the graph. This represents the forecast, and kind of the range here of uncertainty is shown by the graph with the line representing kind of the mean estimate of the forecast. But as I'm sure you know, accurate forecasting is very difficult, and we see from this Danish proverb, it's difficult to make predictions, especially about the future. So at the application level, you can imagine the types of forecasting you might want to do: forecasting of sales, revenues, cost forecasting, etc. The methods that are typically applied in business intelligence tools are fairly simple models that can identify basic trends and seasonal cycles. There are more sophisticated methods such as neural networks that I'll talk about later that can include the effect of many other variables on a forecast. Those are more sophisticated models are the kind of thing that are used by companies for stock market forecasting and automated trading, for example. But the BI tools do provide some basic level of capability in forecasting that can be expanded upon. Decision trees can be used to model the potential outcomes of a multi-level decision process. They represent expert knowledge on the interaction of factors affecting the outcomes of a decision process. In the simple example shown here, ABC company is looking at the trade-offs between different business options, expanding an existing business line, adding a new product line, or doing nothing. The second layer defines the probability of a particular investment being successful or failing, and then the final layer shows the profit implications of that decision. So in this kind of simple analysis here, you can look at an expected revenue outcome, which in this case, they're all positive, but some could be negative, to get a sense of which decision has the most likelihood of positively impacting your business. So as I said, this is a simple example. For very complex decision trees, it can be difficult to establish these outcome probabilities. However, if you have historical data available from the outcome of previous similar decision processes, machine learning methods can be used to learn the decision tree weights automatically. So some other examples or applications of decision trees include ranking which customers should have higher priority in terms of job scheduling, defect root cause analysis on the shop floor, or the outcome of changing inventory levels on operations and profitability, for example. So I mentioned neural networks earlier. Artificial neural networks, as shown in the figure there, represent a cascade of mathematical links that model the relationship between a set of input and output parameters. The individual link weights are learned through machine learning process methods. Neural networks were one of the first model structures developed to try to reproduce human data processing and can be taught to model data relationships, as I mentioned, for forecasting purposes, for example, or for classification. Increasing computing power has enabled modern deep learning networks, which means very large and many level learning networks that can model very complex data sets. These are widely used in image recognition problems such as facial recognition today, and elements of these models are transferable to that are already trained on image recognition are transferable to your manufacturing applications. So neural networks, as I mentioned, are applicable to many data analysis problems. Some of those I haven't mentioned include defect identification and classification, speech recognition. They're widely used in cyber threat recognition and also can be used in schedule optimization or task planning. The last of the methods I'm going to go through here today is text analysis, and they're increasingly powerful tools for automatically extracting information from textual data, sometimes also called text mining or natural language processing. These techniques are very useful for extracting information from unstructured data like websites, social media posts, or documents. Keyword clusters can be extracted in even broader syntactical meaning within paragraphs or entire documents. Some application examples include analysis of public or customer sentiment, analysis of warranty return or customer complaint data from freeform text, classification of documents on your server based on content, or various types of analysis on webmine data, such as competitive pricing analysis. So this is kind of a quick review across a variety of different data analytics methods that are applicable to analyzing shop floor business data and often available in business intelligence tools, which we'll go into in the next section. So this section will kind of close out the presentation and focus on getting started with data analytics. I talked about applications of data analytics at the shop floor level and the business level, and also some of the types of data that can be useful. Business analytics will often use data collected from the shop floor, and shop floor analytics will sometimes use data from enterprise business systems for context. In order to get started, you need ways to store and access critical shop floor and business data. In this section of the webinar, we'll go into some more details on that. So initial considerations as you're getting started, what high-value business and operational questions would you like to answer? What data do I already have access to? What types of analysis and visualization is needed? What type of software is a fit for the organization? How will we resource the development? And what's the cost benefit? So in the next short section here, I'll try to cover aspects of these questions. At the shop floor level, there are many types of software that can support improved data collection. The next webinar on Industrial Internet of Things will cover this area in a bit more depth. There are two main classes of things covered here: machine connectivity and machine monitoring, which support some level of machine preventive maintenance and operational effectiveness tracking, and manufacturing execution systems represented by L2L and Tulip that provide broader insight into shop floor operations and operator effectiveness. These software systems typically provide some level of data analysis capability and some level of visualization and dashboarding capability. And you can see from the ballpark pricing, they're run kind of in order of $1,000 to $3,000 per year, per machine, per workstation. I mentioned earlier that there is a large open source of technology for machine learning and data analytics. And the Python scientific ecosystem is an open source system that we use for R&D that has broad capability. And most of the business intelligence tools can leverage some of the deeper capability of Python if you want to build on top of them. But this kind of approach requires someone that has more capability on the data science and the programming side to build solutions as opposed to buying some out-of-the-box tools. So we kind of already talked a bit about benefits of machine and process monitoring. So the benefits you can expect to achieve are or strive for are improved operational effectiveness and process efficiency, improve process quality, reduce defects, and reducing maintenance cost and downtime. This is a case study example from a company that sells compressors. They implemented data analytics based on data that they were getting off products in the field, and were able to reduce their unscheduled downtime of their customers, for their customers of their product by 60%. A different application kind of looks at data visibility across the entire operation, and you can see here some tools, information distributed by phone or by smartwatch to give better visibility on what's going on the shop floor. This company and a couple of their different operations saw improvements of 5 to 10% in their operational effectiveness. So just to give you a sense of some real case studies there. Moving on to the business intelligence side, there are a wide range of different options in business intelligence software, and there are some fairly good resources available to compare features that you can find online. Some of the leaders based on a Gartner study of business intelligence products include Microsoft Power BI, Tableau. I mentioned those earlier. Tableau is now part of Salesforce, so it's somewhat integrated with CRM, which is a benefit, or Salesforce CRM. Qlik and MicroStrategy are two of the other leaders. It's also worth checking with your ERP vendor to see if they have an integrated business intelligence offering. And you see two companies there that do, Epicor and SAP. Costs can vary widely, but kind of a ballpark is $10 to $100 per user per month. I'll have a little more information on cost following shortly. So we talked about kind of the deeper methods, but at a higher level, what can business intelligence, what are the attributes of business intelligence software, the off-the-shelf software? The basic capabilities that are important are shown here. Good tools for data management are very important to the successful and cost-effective implementation. Many of the methods, as I said earlier, are supported, the data analysis methods, and graphic visualization methods, dashboards, and report are a key element. So we don't have time in this presentation to kind of go through each product, but these are things to consider as you start looking into business intelligence tools. Another important consideration is what kind of resources do you need to support the development of data analytics capabilities. I went through the RIT degree programs and picked out a range of different backgrounds. It should have the technical background to be effective data analysts. And you can see these degrees come from the business school, biology, computing science, and engineering. So there are a lot of people coming out of college have some of the basic tools to be able to do this work. However, specific training and experience in particular business intelligence software and methods will be needed to be successful. So you may obviously have a number of engineers in your business, and they can be trained to do this. At the graduate level, you can see that there are programs, and again, these are RIT programs directly related to data analytics, and that's another option for training your current staff, getting an advanced degree or supporting them through an advanced degree. There are also many free or low-cost online training options. Coursera is one good place to look, coursera.org, as well as other university online degree and certificate programs. Hiring experienced data analysts can be a challenge due to the market demand and the salaries being paid. So internal development can be a good solution. So next we'll talk about the cost of getting started. So this is an example, small company example, where we're looking to have one developer with some IT support, 5 report editors, and 20 report users. And with some of the products, the cost of the user license depends on what their role is. 2 of the lower cost products I looked at costing for are shown here. And you can see for that number of users between $3,000 to $10,000 a year, you can get into the software for business intelligence. When you look at the staff time that's going to be needed to develop the applications and the data access, you're going to be paying more for that. So this is based on essentially one full-time equivalent that you're paying $90,000 with a 50% overhead. So just to kind of give you a sense of what the costs are. Now, once you get some basic applications developed, for example, you build your KPI tools, you may not need to do development in the next year unless you have new applications you want to proceed on. And there are some other potential downstream costs. Usually these are going to occur as you scale up your business intelligence application. So kind of recap what the benefits are on deploying business analytics: reduce costs and errors associated with current manual reporting. You have a single source of truth based on common data sets, as opposed to having your data distributed amongst spreadsheets through your whole organization. More real-time view of organizational performance allows for rapid, proactive response to head-off problems. New insight into root causes of organizational performance issues allow you to do some proactive work as well. And, it allows your organization to evolve into a more data-driven culture that hopefully expands these benefits and multiplies these benefits into the future. So those are not quantitative. There is a reference here to some levels of ROI that this particular research organization identified, kind of at a level 1 of automating reports. They found an ROI of about 188%, and that scaled up to 968% as the tools got broadly scaled within the organization. And you can look up that reference to look at some of the assumptions behind that analysis. Finally, to get started and think about what the implications of getting started are, the cost of software is relatively low and shouldn't be a barrier. It scales well to start at different levels of effort. You'll need to scale your resource that are applied to data analytics, both internal and external, if you're contracting based on the allowable budget and expected time frame and analysis outcomes. Ultimately, you should think about developing or hiring an internal expert that will develop strong understanding of the tools and methods. And since the costs are scalable, you can start small and build on accumulated successes. And make sure you track your costs and benefits as you go along to justify continued investment in new business intelligence or data analytics applications. So I'm running a little bit long here. We'll stay on for questions. I did want to mention that as Cameron said, the program is supported by the Economic Development Administration, and we can, through that program, also support projects, digital maturity assessment, technology evaluation, and implementation support, including the data analytics area or proof of concept projects. And you can reach out to me or any of those listed here. So as I said, we'll stick on and take some questions. Anybody that wants to stick around and ask questions, again, apologize for running a little bit long.
Yeah, thanks so much, Mike, for that great presentation. So again, we'll have some questions here. If you guys have any, please submit them on the bottom right of the screen under the questions tab. Just a reminder that this recording of this webinar will be accessible through the link you clicked to join the webinar. So we'll give a few moments just to let any questions come in. Looks like we do have one.
So one question we have is, we don't have an ERP or MES system. Can we still use data analytics? We kind of look at an ERP as being somewhat of a foundational tool in digital manufacturing because it does centralize much of your data. If you have data in spreadsheets and QuickBooks or other distributed systems, these business intelligence tools do allow for integration from disparate resources. So they can still be used, but they'll probably be less effective than if you had an ERP system. And if you don't have an ERP system, that may be where you want to start. Another question on cloud versus on-premises deployment of analytics. Is one more secure than the other? So that the tools that I talked about, Microsoft Power BI and Tableau, are both available either on-site or in the cloud, and the cost implications are a little bit different. And I think that's true of most of the tools. There are some security issues associated with using data in the cloud, but generally I'd say if you pick a good cloud provider like Microsoft or Amazon Web Services, they have very secure networks and very secure access systems. In some cases, depending on how good your internal cyber readiness is, they may be more secure than an on-site system. So I wouldn't shy away from cloud-based tools, especially in the case of data analytics. Another question. Improving OEE is our number one goal. OEE, operational effectiveness, equipment effectiveness, is our number one goal. Is data analytics a good tool for this? Data analytics is a good tool. We talked about manufacturing execution systems. There are some software systems that have kind of built-in dashboards and also data collection capability. So you do need data off your process to be able to do operational equipment effectiveness or look at the effectiveness of your operators. So in MES may be a place to start. Generally, once you have the data, the business intelligence tools can be applied to that process data. And you can build additional dashboards or KPI analysis on top of the lower level tools. I think we'll take one more here. We have the next question. We have several machines and none are connected. Would you say we should invest in connecting our machines first before thinking about analytics? Again, the answer is a little bit depends. If you're most interested in, kind of relates to the last answer, operational equipment effectiveness, then you will need that data. However, on the business side, the business intelligence type applications we talked about don't necessarily need access to the data from your machines and can still offer pretty significant benefits, particularly, and we talked about a number of the benefit areas there. So at the business level, in terms of driving your business level KPI, if you have an ERP system, a CRM system, you can go a long way with the business intelligence tools. And I think we'll leave it at that. Thanks again for joining the webinar today. And if you have any questions, feel free to reach out to us. I think you'll get, Cameron will be sending out, or the software will send out a link so you can access the webinar to review it again. Or Cameron, I don't think the link can be passed on, but if anybody else in the organization is interested, they can contact you for a link, correct?
Correct. Yep. Just reach out to me and we'll be able to share that. You can access the recording by joining the same way you joined today. And feel free to do that at any time. We will be back next Thursday at 11 a.m. with another webinar, and that topic will be leveraging the industrial Internet of Things. So make sure to mark your calendars for that if you haven't already. We want to thank the EDA again for sponsoring this webinar series. Thanks again to Mike, our presenter. And if that's all we have, Mike, I think we'll see everyone next week. All right. Bye-bye now. Thanks.